So let's develop a couple of ways to compute scientific notation operations. So if we wanted to multiply two numbers that are both in scientific notation format, we multiply the numbers, the a and the b, then we multiply the bases of the 10. 10 to the n times 10 to the m produces 10 to the n plus an m. So we're using a combination of both our exponent rules and our normal multiplication rules. Dividing two numbers that are in scientific notation, we'll first divide the a and the b, and then look at the powers of 10 and subtract the powers of 10 from each other. And then with a power rule, we have an a times 10 to the nth raised to an m power. We distribute that m across both of those terms. So let's look at a couple examples here to kind of help make sense of this. So first of all, we have 4 times 10 to the 5th times 2 times 10 to the 9th. According to our model here, we're going to take the 4 times the 2 first, which is an 8, and then look at the powers of 10. 10 to the 5th times 10 to the 9th. We add those exponents, so that becomes 10 to the 14th. 1.2 times 10 to the 6th divided by 4.8 times 10 to the negative 3. First of all, we do the 1.2 divided by the 4.8. That produces a 1 over a 4. 10 to the 6th divided by 10 to the 3rd. That makes that 10 to the 6th. Take away the denominator, which is a 3. And to simplify that, that's going to be 4 on the denominator, and on the numerator, I have 10. Well, let me back up here. I got carried away. Let's redo this differently here, folks. That's going to be, all right, 1.2 divided by 4.8. I automatically went to fraction form. I forgot we're leaving it in scientific notation form. So 1.2 divided by 4.8 is 0.25, basically 1/4, times 10 to the 9th. From there, it's not in scientific notation form. Notice that my first term is not a number between 1 and 10. So I need to rewrite this as 2.5 times 10 to the, what am I going to do? Am I going to make this an 8 or a 7? How I think about this number, I'm going to increase this number by a factor of 10, which means I need to decrease this number by a factor of 10 in order to maintain its equivalence. 0.25 times 10 to the 9th is the same thing as 2.5 times 10 to the 8th. Needs a little bit of practice, but one way to get used to thinking about that is this number, in order to make this an appropriate scientific notation, this number is going to have to be increased by a factor of 10. To maintain the balance, I need to decrease that number by a factor of 10. Follow with that one? You also got to watch me make a mistake early on too. I make mistakes all the time as well. And then 5 times 10, well, I have 5 times 10 to the negative 4th to the 3rd. Well, this model tells us is this becomes 5 to the 3rd times 10 to the powers, negative 4 times the 3, which is a negative 12. That's non-scientific notation. So 5 cubed is 125 times 10 to the negative 12. 125 is not in scientific notation format because it needs to be a number between 1 and 10. So the decimal point really should be here at 1.25. I made this number a factor 210 smaller, 100 times smaller. So I need to make this number 100 times bigger, which makes it from negative 12 to negative 10. 10 to the negative 10 is 100 times bigger than 10 to the negative 12. 1.25 is 100 times smaller than 1.25. Now, This will take some time to get used to of how to convert numbers and simplify them in scientific notation. That's going to take practice. It's going to take practice knowing how to raise or lower an exponent when you're doing that. Because sometimes trying to understand on the negative side what's a bigger negative number than another may take some time. So please practice those, but you can compute scientific notations.